Overview of what we do in the region of Montpellier concerning precision viticulture. Basically, precision agriculture was born in the 90s, and the concept is based on the fact that we want to apply the good quantities of fertilizers at the good place, the good time, good quantities, and that was applied to viticulture afterwards. The first example that we have had on this topic was yield sensors that were embedded on tractors and could lead to mapping of yields in this way with a very high resolution. The feedback of this first experience was rather mixed in the sense that actually only a few number of big companies could afford to have this kind of systems, and there was only one manufacturer today. The big company could afford to have this kind of system because they can afford to have whole fleet equipped in the same way. They can afford to have specialists in geoscience. And the interest for other structures or bodies was rather low. If I consider traders or cooperative wineries, there is too high heterogeneities of supplies and types of harvesters that lead to difficulty to collect and consolidate heterogeneous data. For producers or at the vineyard scale, there is a necessary skills and investment that are very high. And an important aspect is that people don't need only to have information on yield at the end of production, but they need also to have information all during the life of the production. I go fast. So there were new specifications. We need to have data during the whole production cycle. We need also tools that build, which are really decision support tools. Sometimes it happens that people with yield data, they don't know what to do with this kind of data. So they need something that transforms the raw data into valuable and relevant information. And a common aspect that appeared is that we need both geospatial information and temporal information. We have to combine these two types of information. So this is an example of what has been done in Montpellier. The name of the product is Inovisa, based on remote sensing, and it enables to map the different plots of a vineyard. And the interest is to see the heterogeneity between plots and to adapt the management, adapt the harvest, or also to adapt to adopt selective sampling. This is also the illustration of this mapping. You can see the heterogeneity within plots, and you can adapt your management within plots also. Another example is proxy detection of grass using specific sensors. So there are several commercial solutions that exist now, and that are interesting for grass management, and ultimately can lead to a real adjustment of the quantities of pesticides that will be applied on the plot. Another example is TICSAD. TICSAD is a system on the tractor. The tractor is equipped with GPS receiver antenna and coupled with a sensor which can record the spray results. So when you apply herbicides on the plot, you can see a posteriori, so after the treatment, if the spray was correct or not. When you have the green dots, you have the good quantity was applied, and when you have yellow or red dots, you know that the spray was not good, or maybe you forgot some areas of the vineyard. Soil conductivity mapping is quite well known now. It is based on the conductivity properties of soil, and it is used for optimized crop management or plantation for treatment and so on. This is made by Jakarta. In the same way, some companies, there are many companies that have developed local sensors that can record very detailed information, but with a very high temporal accuracy. These sensors record climate information, soil water, water demand, water stress. And what is interesting is that to overweight the fact that these sensors are locally positioned, the companies have developed systems to build a network of sensors, and these sensors can communicate with each other, which means that you can see on this picture several sap flow sensors have been set up, and they communicate with each other, and all the data are gathered, collected, and ultimately you can monitor the system using a website. The new tendency goes to handheld sensors. For instance, you have Spectrum that can give you information on the maturity of grape and help you to decide whether it's the good date or not for harvesting. Multiplex is sensors which will give information on the physiological and physiological status of the plant, and will particularly help in giving information on whether fertilization is required or not. Quality's GRAP is another handheld sensor that will help predict the yield and quality of the production. And this is very important because producers need to have very accurate information to monitor wine production, grape production, and this will have a very close connection with the wine quality. Okay, and to go further, we can also have a link with tools and information system at the winery level. Here you have a system, Quality's Reception, which enables to check grape quality at reception. Check if it's clean and if the color is really is really good. Ongoing research on viticulture precision. Okay, so I mentioned optical properties, remote sensing. We are working on the TICSAT system for traceability. More and more, we are trying to develop applications for smartphones. In the same way, we need information. We need to develop methods for interpolation. As I mentioned just previously, we can have punctual information with very high temporal accuracy, but now we have to develop methods to see how to extrapolate this information to a whole area, based, for instance, on satellite imagery. So this is an illustration of what we are imagining. This is an overview I presented just previously. This is the application for smartphone, and from the smartphone we can have an application that gives automatically the good sampling design. Okay, so as a conclusion, there are issues of spatial heterogeneity assessment, vegetation mapping, phytoproduct application monitoring for environmental and economical impacts, follow-up of water and physiological status for, especially for water or nitrogen supply monitoring. We need also a very tight follow-up of production quality, forecast wine quality. This is a very important aspect. And there is a tendency for the development of, as I said, handheld standalone sensors. And I can see two different ways of developing this kind of sensors. There is one way with high-value information and rather expensive sensors versus the second way, which is develop small sensors, very handy, practical, that should be available using a smartphone. The other main issue is geographic and temporal information, so we need interpolation methods and sampling design methods. And the two other issues that are linked to these topics is interoperability, which means that we need some systems that are able to communicate with each other, which are able to communicate, to be integrated in the existing system information in the winery or at the farm level when they exist. And for this, we need also data exchange standards. And the last issue is that we have to make links with robotics application in order to have automated systems of treatment at the vineyard level. So, this is the end. We are very involved in building projects with this kind of topics. 2 months ago, we built a few proposals for the ICT Agri Call project, which is a transnational call for project. And of course, I invite any of you to join if you want to build something with it.